Okay, I'm going to show you the Euclidean algorithm. Let's take the numbers 24 and 60. Now what we're going to do is we're going to take the smaller number and divide it into the larger. Of course, 24 goes into 60 two times, leaving us a remainder of 12. Now, let's take the remainder and divide it into the previous divisor. Just dividing the smallest number into the next smallest. Okay, 12 into 24 is 2, with a remainder of 0. It follows that 12 is the greatest common divisor. Okay, 12 is the number we end up with, and it turns out that 12 is the greatest common divisor of 20 and 60, as you can easily verify. 24 and 60, that is. What if we wanted to find the greatest common divisor of 24 and 64, for example? Okay, let's see. Greatest common divisor of 24 and 64. Well, divide 24 into 64. Again, we get 2. We get 48 down here. We get 16. Remainder of 16. Now we take the 16 and divide into 24. And we get 1 with a remainder of 8. And then we divide 8 into 16. Didn't leave myself a lot of room here, but 8 into 16 is 2 with a remainder of 0. Now, when we get down to remainder of 0 in this process, our last divisor is the greatest common divisor. First time we hit a remainder of 0, we're done, and we've got the greatest common divisor. That's the Euclidean algorithm. And you can actually see how that works if you think in terms of prime factorizations and so forth. Okay, but it's kind of a neat way, it's kind of a slick way to calculate a greatest common divisor, and it has some theoretical interest if you actually get into the proof of it, which we won't do in this course.